In this video, we're going to take a look at conductivity, and specifically, we're going to look at conductors and insulators. So, by the end of this video, you're going to be able to explain how different materials can either be conductors or insulators. And you'll also be able to apply how we use conductors and insulators to the real world. So, let's just get right into it. Now, we first need to talk about conductivity. So what is conductivity? Well, it's the ability to let electrons move freely through the material. So how much it moves or how quickly the electrons can move through the material is going to affect its conductivity. Now, what's the difference between this and electron affinity? Well, electron affinity, remember, is the likelihood of giving electrons or receiving electrons, whereas conductivity is how fast electrons can move through the material. So, if something has high conductivity, we would say that it's a conductor because they allow electrons to move easily through the material. Whereas if something does not allow electrons to move easily through it, we would say it's an insulator. So let's look at some examples of those. Now, as I just said, conductors allow the electrons to pass through. Okay, so examples of good conductors are things like metals. So silver, gold, copper. Seawater is also a really, really great conductor. Insulators, on the other hand, don't allow the electrons to flow through or flow through very, very small amounts. And so those are examples are things like glass, rubber. It's great for our tires because we do want them to be insulators, plastic, oil. There's all sorts of different types of examples. Now, sometimes we can have materials that will allow electrons to move, but not as much as a conductor. Those are called fair conductors, FAIR conductors. So there is sort of a varying range of how conductive something is. Now, in terms of real world uses, there's some really good examples of conductors and insulators. One is the wires in our home. So, wires actually are composed of both conductors and insulators to direct the electric charge in a specific path while also protecting our homes. So, for example, inner wires in our homes, the wires themselves are made usually out of copper and they are great conductors. So, they allow the flow of lots of electrons. The wires themselves are insulated. So, they're usually covered in this protective layer of rubber. And that's an insulator that makes sure that the electrons don't escape from the wire. And that way, the electrons can only go along the wire, along the copper conductor, and they can't go anywhere else. So it makes it really, really efficient as we're conducting electricity through our homes. Now, the question comes up: is water really a conductor or an insulator? And the question depends on what kind of water you have. Now, if you have distilled water, so this is water that is completely pure, it has nothing else in it, it is actually quite a good insulator. If we were to connect it up to a circuit and we connected a light bulb there, the light bulb would not glow because there's no electrons that are flowing through our circuit. Now, most water has impurities in it. So it has different minerals, um, things like magnesium or calcium or copper, all kinds of different minerals that are actually really good conductors. And so our tap water or any other water that has these minerals in it, in nature even, turn water into a pretty fair conductor. And so that's why if you were to create a circuit, the same kind of circuit with tap water, a light bulb would glow because electrons are flowing through this circuit here. It's also why if you see a broken wire in water, you want to stay away. It's totally going to electrocute you, and you do not want that to happen. That's it then for this video. Let's move on to our next task.